Good morning, students. We are discussing about polymer, which is the unit of 3 paper of 7th B. General polymer like as PVC, Teflon, polyacrylonitrile, polymethyl methacrylate, nylon chassis, as so on. But we already studied that a polymer which is prepared by Ziegler and Natta. This is very important polymer to which prepare hydrocarbon. Ziegler Natta catalysis. These are special type of coordination catalysis comparing two components as against single component. Organometallic compounds that we came across earlier. The two components are generally referred to as the catalyst and to co-catalyst. The catalyst compound consists of halide 6 group, 6 to 8th group in periodic table. Element having transition valency and the co-catalyst are organometallic compounds such as alkyls, aryls and hydrides of group 1st to 4 metals. Although there are hundreds of such catalyst co-catalyst system, those based on organoaluminium compound, this is important. Ziegler Natta having organoaluminium compound such as triethyl aluminium, AlEt3 triethyl aluminium or diethyl aluminium chloride. 1Et is substituted by Cl in combination with titanium chloride. Both tri and tetra, titanium chloride and titanium tetrachloride. Tri is titanium trichloride and tetra is titanium tetrachloride are by far the most commonly used aluminium alkyls. Act as the electron acceptor and the electron donor is titanium halide, and combination therefore rarely forms coordination complexes. The complex formed is insoluble in the solvent, hence heterogeneous in nature. Many structures having been proposed. This is the trialkyl aluminium and trichlorotitanium. You see that aluminium and alkyl partially bonded, alkyl and titanium is partial bonding and dissociated in dichlorotitanium and chlorotriethyl aluminium. After that, titanium having one valency shell, one valency space. Titanium 3 space occupying by 3 chloride and 2 space occupying by 4 space occupying by chloride Cl4, and 1 is alkyl and 1 is vacant. The vacant is active center. The active center from where the polymer chain growth propagates are formed at the surface of the solid phase of the catalyst complex, and the monomer is complexed with the metal ion of the active center board with its insertion into the growing chain. The actual mechanism by which is propagation takes place and the factors growing the formation of stereoregular polymer formed a topic of great debate at one time. Among the several mechanisms proposed, the bimetallic mechanism of Natta and the monometallic mechanism of choose had received much attention. Causes mechanism, however, is the one that is widely accepted presently. We shall, however, look into both these mechanisms. Natta is tell about a monometallic mechanism. Natta bimetallic mechanism stipulated the following: when the catalyst and co-catalyst components are mixed, there occurs chemisorption of the aluminum alkyl. Aluminum alkyl is electropositive in nature. Aluminum alkyl tri-alkyl aluminum, because aluminum having 3 electron deficient species. It means we can say that electropositive in nature. On the titanium chloride solid surface, resulting in the formation of an electron deficient bridge complex of the structure. This is the structure: dialkyl aluminum and dialkyl titanium, and partially bonded with alkyl and chloride. This complex now act as the active center. The monomer is then attracted towards the titanium carbon bond in the active center when it is form a pi complex with the titanium ion. So this is the structure: aluminum and alkyl group, titanium and chloride group plus alkene. Alkenes are bonded with vacant site of titanium. That bond between R and Ti opens. R and Ti opens up, producing the electron deficient titanium and carbanion at R. This is the structure. This is the complete reaction. The titanium attract the pi electron pair of the monomer and forms of a sigma bond, while the counter ion attract the electron deficient center the monomer in the way inserted into a transition state ring structure. This structure is a convert into transition structure, positive negative partial bonding, that being form a transition state. This transition state now gets rise to the chain growth at the metal carbon bond, regenerating the active center. This is the structure after the transition state. Repeating the whole sequence with the addition of a second monomer molecule, we will get the structure of resultant chain growth. Chain growth is the important step in polymerization. The monomer insertion the repeated in the manner and the orientation of the substituent group of the monomer is always taken from the metal ion and resulting in the stereoregulated polymer. On the other hand, the monometallic mechanism proposed by the causes assume that active center is the titanium alkyl part of the catalyst, while the aluminum alkyl perform only the function of the alkylating the titanium tetrachloride. When the catalyst and co-catalyst are mixed, the aluminum is chemisorbed on the solid titanium trichloride. The 5 coordinated titanium ion on the surface of the catalyst assumed to have a vacant d orbital, as shown in that. This is the vacant d orbital. The chloride N1 and 2 are assumed to be attached to another titanium in the crystal lattice of titanium trichloride and accept the chloride at 5, which can be replaced by an alkyl group. All the other 4 Cl are non-exchangeable immediately after the chemisorption of the aluminium alkyl on the titanium trichloride crystal. Titanium chloride is having +3 oxidation state. That titanium 3 plus is the alkylated when by an exchange mechanism. This is the exchange mechanism. Titanium having a 3d orbital vacant and pentachloro, one is a vacant space. Triethyl aluminium are react with that, and titanium vacant position bonding with ethyl, and chloride is also partial bonded with aluminium, because chloride is electron negativity more electron having than aluminium is partially positive, because aluminium's octet deficiency. Outermost electrons shell having only 6 electrons that partially bonded between aluminium and chloride. After that, Et is completely bonded with titanium, and vacant position are converted by Cl. Cl is going to with aluminium. The active catalyst now formed as an octahedral structure with the 4 Cl attached to the lattice, and the ethyl group attached position where originally the 5th chlorine was attached. Once the active catalyst is formed, the monomer is attached towards the vacant d orbital. This is the structure, vacant d orbital. From above structure, ethyl and tetrachlorotitanium react with haloalkene. Haloalkene that bonded with titanium. This is the second structure, and convert into a transition state. The transition state quickly gives rise to growth up of the polymer chain. The transition state quickly gives rise to the growth of the polymer chain by the monomeric insertion at the titanium and ethyl bond. While that orbital can either regenerated at the same position or the position where the ethyl group was originally attached. This is the reaction. This is the transition state. Convert into above that haloethyl alkane with titanium and haloethyl alkane with titanium. First is above position, second is this position. When the vacant d orbital is regenerated at the same position of the time, incoming monomeric unit will be inserted with the same spatial arrangement, resulting in the formation of an isotactic polymer. With the insertion of each monomeric unit, if the d orbital migrates from the one position to other alternatively, the monomers get inserted with the alternating spatial arrangement, resulting in the formation of the syndiotactic polymer. Whether the vacant site is regenerated at the same position or migrates to the other sites alternatively would depend on the interactive forces existing between. One is the substituent group of the incoming monomeric unit and the already inserted monomeric unit, and second is the substituent group of the monomer and the chlorine atom of the active catalyst. Factors such as the type of a catalyst system, catalyst crystal structure, molar ratio of the catalyst components, and temperature of the catalyst complex influence the shift of migration of the vacant d orbital and hence the stereoregularity of the polymer formed. Whatever be structure of this active center and mechanism of the active center formation, the polymerization is characterized by the initiation, propagation and the termination step. These step is in polymerization. First is the initiation, second is the propagation and third is the termination. First is initiation, that the presence in a H nu, it means photon, ultraviolet light initiated this step, and haloalkane is initiate active member of this, and haloalkane react with and to form a initiator. Initiator after change in propagation, and propagation is the chain growth stage, and last is that chain termination state and form a compound. This is the Ziegler natta catalysis. This is the part of unit 3rd paper of 7th B in M.Sc previous part, unit number 3rd, part number 3rd A. This is the important topic for the M.Sc chemistry. Ziegler natta work on this catalysis and to honored by a Nobel Prize. Okay, myself Dr. Rajaram, Assistant Professor, Government Dungar College, Bikaner. धन्यवाद.